All right, MDI today, we're just using this area formula here to figure out what the area of the circle is. So remember that R means radius. And radius is from the center of the circle to the edge of the circle. So it's halfway across the circle. So to do the area for this one, we would take A is equal to pi times 4.7 squared. And if you think about your order of operations says that you have to do exponents before you do multiplication. So we need to square this first, and then once we square that, then we can multiply it times 3.14. So 4.7 squared is 22.09, and then we're just going to multiply that times 3.14. And we get 69.36. And since it says round to the nearest tenth, we would say that the area is equal to 69.4. And we know that our label this time, or our unit, is inches, so we would label it as inches squared. On the second one, we have to be really careful because this 9.2 represents the diameter, but we only want the radius. So in order to find the radius, the first thing we have to do is we have to take the diameter, 9.2 divided by 2, which is equal to 4.6 centimeters. Once we know what that is, then we can substitute that in for the radius. So we can do 4.6 squared times pi. 4.6 squared is 21.16. And then we're just going to multiply that times 3.14. And we get 66.44. And when we round that to the nearest tenth, we would just get 66.4. Our unit this time is centimeters, so we will label centimeters squared. So today we're going to talk a lot about area. So what the launch is how much more pizza is in a 12-inch diameter pizza than in a 10-inch pizza. So again here, since 12 is our diameter, first thing we need to do is take 12 divided by 2 so we can find what the radius is. And then to find what the area, we would take 6 squared times pi, or times 3.14. So A is equal to 36 times 3.14, which is equal to 113.04. The area for the smaller pizza, again, we have to find the radius first because they give us the diameter. So we have to take 10 divided by 2, which is equal to 5. So then for the area, we would take 5 squared times 3.14, or times pi, which is 25 times 3.14, and we would get 78.5. The question is asking us how much more pizza in this one than in this one. So in order to find how much more, we would just take the 113.04, subtract out the 78.5, and we would get 34.54 inches squared. So there are 34 and 5/10 more inches squared in the 12-inch pizza than in the 10-inch pizza. All right, today what we're going to be talking about is calculating the area of circles and sectors. So we'll talk about what a sector is in just a second. Just a reminder, a couple of things first. Pi is the ratio of a circle's circumference to its diameter. So if you were to take the circumference of a circle and divide it by the diameter of the circle, what you would end up with is pi, or 3.14, the approximate value of pi. Pi is also the area of a circle whose radius is 1. So if you have any circle and the radius of that circle is 1, then we know that the area is going to be pi times radius squared. 1 squared is 1. Pi times 1 is pi. So the area of any circle whose radius is 1 is automatically going to be pi. And then the way that they get pi, the way that they approximate pi, is by taking 22 divided by 7, which ends up being approximately 3.14. All right, Another reminder is that the arc is the outside part of the circle, the curved part of the edge. The angle is the inside part of the circle here, so the part that's around the center. And if it's a central angle, we know that the central angle is equal to the arc that it is intercepting. All right, so first thing we want to do is we want to define what a sector is. So a sector is kind of like, think about a pizza, slice of pizza or a piece of pie. It's a wedge. So it's bound by the two radii, and then it's everything in between those two radii. So this part right here that's shaded in would be considered a sector of the circle. We know that since the central angle in here is 45 degrees, then we know that this arc out here is also 45 degrees. So what we're going to do is we're going to try and derive the formula for the area of just this little wedge right here. So if we wanted to find the area of the circle, we would need to use pi times radius squared. And I forgot to put the radius up here. The radius is 1. So to find the area of the circle, we would just do pi times radius squared. So in this case, we would have 1 squared times pi, which is equal to 1 times pi, which is equal to pi, or 3.14. All right, what fraction of the circle is the shaded sector? So if I were to put this up here, put this box up here, and I shaded this and I said, what fraction of the square is shaded? You would say 1/9, because 1 represents how many boxes are shaded in, and 9 represents the total number of boxes. Well, in a circle, we don't have a box, and we can't really measure it in length. So the way that we measure a circle is in degrees. So in order to figure out what fraction the circle is of the shaded sector, we would have to figure out what the measure of that arc length is, and then divide it by 360, because there are 360 total degrees in a circle. And then if we can figure out what the measure of that arc is, it's kind of like saying, okay, 1/9 of this is shaded. We would have to figure out what portion of this is shaded as well. So in this case, we have 45 over 360. And if we simplify that fraction, both of these are divisible by 45. So the fraction that this represents would be 1/8. So this shaded portion represents 1/8 of this circle, which means that its area should also be 1/8 of the circle's area. So if we want to find the exact area of the wedge, what we would need to do is figure out what 1/8 of pi is. So what we're going to do is we're going to take the measure of that arc length, the measure of the arc over 360, and we're going to multiply it times the area of the circle. So we can see that, move this up just a little bit, we can see that the measure of AB over 360 is this 1/8 here. And we know that the area of the circle is pi, so we're going to take that times pi. And we can turn any number into a fraction just by putting a 1 underneath it. And then all we do to multiply two fractions is just multiply top times top and bottom times bottom. So 1 times pi is pi, and 8 times 1 is 8. So this here is the exact area of that wedge. If we want to find the approximate area of the wedge, we just need to take out the pi and replace it with 3.14. So the approximate area would be 0.4, or you could get 0.39. All right, so this is that formula that we just talked about. And the reason that I have area highlighted here and this boxed here is because this is just the formula for the area of a circle. Okay, so if we're finding the area of a sector, then what should be after the arc is the area of a circle. So we're just finding out what portion of the total area is this wedge here. Okay, and we're going to be learning another formula next week that's really, really similar to this. It's arc length. And so it's really important to remember that area of a sector uses formula for the area of a circle at the end. All right, so we're going to do just a couple of examples, and then the assignment is at the end of the video, or is at the end of the Google Classroom. Is on Google Classroom. I cannot talk today. All right, so first thing we want to do is let's just start off by writing down the formula. So we're finding the area of each sector. So remember, the sector is the wedge. So what we're doing is we're trying to find the area of just this wedge in here. Or I guess I could just outline it like this. Just this wedge right here. And I'm going to label this, since they did not, we'll call this A, and we'll call this B. So we've got the area of the sector is equal to the measure of arc AB over 360 degrees times the area of the circle, which is pi times radius squared. So then the parts that we need to replace are this measure of arc AB and the radius squared. So in order to find the measure of arc AB, we have to know what this angle is right here. So we know that this little corner here means that this angle is 90 degrees, so then also this arc is 90 degrees because central angle is equal to its intersected arc. Okay, so we have the area is equal to, the measure of arc AB is 90 degrees over 360, and this is always going to be 360 because there are always 360 degrees in a circle. The radius is this part right here, so we're going to take 16 squared, and then I'm going to put pi at the end because usually that's where we put pi, is at the end. So once we plug everything in, then what we need to do is we need to simplify our fraction. So if you guys remember, the trick with the zeros at the end is you can cross off both the zeros. And so really what we're simplifying is 9 over 36. So I'm going to divide both of these by 9 because I know that they're both divisible by 9. So 9 divided by 9 is 1. 36 divided by 9 is 4. And then 16 squared is 256, and then we still have that pi at the end. So we just simplify the fraction, and then we square the radius. And then remember, we can turn any number into a fraction just by putting a 1 over it. So when we multiply fractions, we just multiply straight across. So the area is equal to 1 times 256 pi is 256 pi. 4 times 1 is 4. And the last thing we need to do is we need to check to see if this 256 over 4 is divisible, if it comes out as a whole number. If it comes out as a whole number, we're going to simplify it. So 256 divided by 4 is equal to 64. So we're going to change this to be A is equal to 264, sorry, not 264, just 64, 64 pi, and the unit here is centimeters, so we'll put centimeters squared. All right, let's look at the second one here. So the second one, we have this funky little symbol that I don't know that we've seen before. And all this is it's the Greek letter theta. And all theta tells us is the angle measure. So here what they're telling us is that the central angle is equal to 240 degrees. So in order to find the area, again, we're going to start with the formula. So area of a sector is equal to measure of the arc over 360, because there's always 360 degrees in a circle, times the area of the whole circle, which is pi times radius squared. Again, the two pieces that we are going to replace are the arc, the measure of the arc, and the radius. So In this case, this represents our arc, the measure of our arc, and here's our radius. So we're just going to plug those into the appropriate spots. So area is equal to, the measure of the arc is 240 degrees over 360, always 360 because there's always 360 degrees in a circle, times our radius is 11 squared times pi. So again, we want to simplify our fraction, then both end in 0 so we can cross the zeros off. So really, we're simplifying 24 over 36. These are both divisible by 12. So 24 divided by 12 is 2. 36 divided by 12 is 3. 11 squared is 121, and then we have the pi at the end. So again, I'm going to turn this into a fraction, and when we multiply fractions, we just multiply numerator times numerator, denominator times denominator. So 2 times 121 is 242. Don't forget your pi. 3 times 1 is 3. And again, we're going to check to see if we can divide 242 by 3. So 242 divided by 3 is equal to 80 2/3, but instead of writing that as a decimal, we're just going to leave it as a fraction. So the area of the sector is 242 pi over 3, and our unit this time is inches, so but we're going to put it as inches squared. And there we go. The assignment for today is the worksheet 5.5, connecting area and circumference. That should be finished by Monday, the 17th.